Okay, so pretty basic day today. I'm going to go over a couple examples, I think like 5 total, just to kind of get you reminded again of what slope is like, and something called discrete and continuous. You talked about it, stop talking please. You talked about it very little in the video that you watched last week, but I feel like there probably is some explanation that needs to be said more to that, okay? After that, you're going on Edgenuity, you have the instruction, and then that's just it. You're done after that, okay? You don't need to submit your notes. Please make sure if you're online, especially for the kids who are normally in person, but they're online today, please make sure you're taking attendance so you don't get marked absent, period, okay? All right, so let's do this. You don't need to write anything down, but just listen, okay? Trust me, there will be days, probably starting next week, where you will need to write things down, but I feel like everything is still kind of a review right now. It should be a review, or the concepts are basic enough where we really don't have to write something down because you kind of already know it, okay? Or it's kind of self-explanatory. Okay, so here we go. For this question, it's saying determine whether the domain is discrete or continuous, and then explain why. So remember how we talked about a long time ago, I think this was last week, something about whether something is discrete or continuous, okay? So let me kind of explain. Discrete is separate points, as in like if I were to graph this, it would just be dots. So like it would just be like 1, 2, 2.5, 3, 4, whatever, okay? You couldn't connect the dots because you can't have a fraction of that number. So for example, if I have like the number of DVDs, that would be discrete because I can't have 1.7 DVDs, right? Or if I had like the number of cows, I can't have 2.6 cows. So anything where you can't have a fraction of that number, it has to be a whole number, that would be something where it's discrete. Whereas continuous would be if I have dots, but I can connect them with lines in between. So things like time, I can have a fraction of time. I can have 0.3 hours. Or if I had money, though money's never on the bottom, but if it were money, I can have, $2.3 or $2.30. Or if it was like miles, like distances, I can have 7.6 miles. So all of those things would be considered continuous because I can have a fraction of that many. Okay, so that's how I decide if something is discrete. I can't have a fraction of that word, or continuous. I can have a fraction of that word. So here it says determine whether the domain is discrete or continuous and then explain why. So first of all, they're just asking about the domain. So guys, the domain, is it X or Y? X. The domain is X. So if I'm only thinking about the X's, am I thinking about the months or the height? The months, right? So I can cross this out. I don't even care about that. I just want to know if I were to graph this situation and months is on the bottom, could I have a fraction of a month? Can I have like 1.5 months? Yes, right? I could have a fraction of a month. I could have 2.6 months, right? I can break it up into fractions. So if I can have a fraction of this word, is it considered discrete or continuous? Continuous. Okay, so discrete means I cannot have a fraction of that word. Continuous means I can. So I can have continual months. Months can go on and on and on forever and everything in between. So this would be considered continuous because you can have a fraction or a decimal of a month, right? You can have 2.9 months. So you're only looking at this word. You're not looking at the whole thing because it's just asking you about the domain. All right, so let's try this one then. Okay, I'm comparing tickets with dollars, cost. And I'm looking at the domain. So really, I'm only looking at which word, tickets or cost? The tickets, right? I only want the X, the domain, so I don't really care about this. So all I really care about is the word tickets. So when you want to say if it's discrete or continuous, think to yourself, can I have a fraction of a ticket? No, I can't have 2.5 tickets. Either you have 2 or you have 3, right? You can't have a fraction of a ticket. So If you can't have a fraction of that number, is it discrete or is it yeah, it's discrete, right? It's not continuous because you can only have 1 ticket, 2 tickets, 3 tickets, 4 tickets, 5 tickets. So I would say this is discrete because you can only have whole number of tickets. Or you can say you cannot have a fraction of a ticket or something like that. Yes, Rowan?
Of course, if you did have a fraction of a ticket, I don't think they would accept it.
Exactly. So it wouldn't make sense in the real world. So that's why you would have to think to yourself, is it discrete or is it continuous? Okay. Let's skip this one because this one's super tricky, I feel like. But let's do this one. Okay. This picture. So determine whether the domain is discrete or continuous, and then find the domain of the function. So let's find the domain first. So we said the domain is x's. So this is what we did last week. Does anyone think they know? Can you raise your hand, please? When I write the domain, am I having the inequalities or am I just having like a number, comma, number, comma, number? What do we think, Tessa? Yes, it's just going to be a bunch of numbers with commas in between. Now, Tessa, why is it just a bunch of numbers with commas in between? Because the dots aren't connected. That's exactly why. Okay, does anyone think they can take a stab at this? What are the numbers of the domain? Yeah?
1, 2, 3, 4, 5, and 6.
Thank you. 1, 2, 3, 4, 5, 6. Domain is just the x-axis, right? It's just the x. So where do these dots hit the x? At 1, 2, 3, 4, 5, 6. So that would be it. Well, I would really hope that just by seeing this, you can decide whether it's discrete or continuous. So can someone different raise their hand and tell us, is this picture or is this thing, doesn't matter what you look like or look at, is it discrete or continuous? What do you think? Yeah.
Discrete.
Good. Okay, Cameron, do you think you can say why though?
Because there aren't like any decimals or fractions.
Okay, because no decimals of the numbers, I guess you can say, no decimals or fractions, what Cameron said. You can say the lines or the dots are not connected. Any of those reasons, but you really have to know that it's discrete. And then your why probably supports that. So something that kind of goes around that. Okay, you're good. All right. This one then, first of all, finding the domain is a little bit more tricky. Does anyone think they know for this one? Raise your hand, please. Is it going to be like this, where I have a bunch of numbers with commas, or is it going to have the inequalities? What do we think? Luis? Okay, so it's going to look like this. Luis, why is it going to have the inequalities? Okay, it's not just points. Everything is connected. That's why. Okay, so now does anyone think they know it goes from what thing to what thing? Luke?
It goes from -2 to 2.
Yeah. So if you look at just the x's and maybe you want to like box it in because there's no arrows, where do your x's go from? It goes from the -2 right here all the way to the +2. So that's my domain. Okay. So just by looking at this picture, you should be able to decide if it's discrete or continuous. What do we think? Someone that has not spoken yet. What do you think, Kip?
I think it's continuous.
Good. Why?
Because you can have like fractions, because the lines go through like not all whole numbers.
Okay, so the line goes through not whole numbers only. Perfect. Like, do you see how basically it's connected? If it's connected, it's including all the decimals in between. So you can have a decimal of that x. Yes, Tessa?
If it was like separate dots like the last one, could it still be continuous?
Okay, good question. So if it were just separate dots, then it could not be continuous because it's telling you that it's only at this dot and this dot and this dot. So it's not continuing on in between. Basically, that's what continuous means. Luis?
What if there's like a dot in between like 3 and 4?
Okay, so that's a good question. So what if there's a dot at like 4.5? Okay, it's not a whole number. So is it discrete or continuous? It's still discrete because it's still just that specific dot. So I think the easiest way to explain whether or not something is discrete or continuous is whether or not you can have a fraction of that number. But maybe you are going to have a fraction of that number at 3.5. But maybe that situation, it makes sense to have a fraction. Like maybe, I don't know, like you're going to an arcade and every game costs 50 cents. So either it's $1 or $1.50 or $2 or $2.50 or $3. So you're going in increments of 50 cents. So it would be okay to have the 50-cent mark, like the halfway point, the fraction, but it's only that amount. Does that make sense? It's not like every possible fraction in the world, because if it were every possible fraction in the world, then you would be connecting all your dots together. Okay. This one. This is the trickiest one. This morning, so like it's been an entire year, right, since I've even taught this. And so I had to look at it for a good like 3 minutes and be like, wait, how do you do this again? Like without guessing and checking. I know that you can maybe like guess, oh, add 1, 1, 1, 1, 1, and see if you get here. No, okay, add 2, 2, 2, 2, 2. Like you can do it the elementary school way. But does anyone think they know how to do this the mathematical way to get the exact numbers here? Okay, I'll give you like 30 seconds to think about it. Okay, because it took me like 3 minutes and I actually have to really think like, wait, how did I do this again last year?
Can you just input in your calculator?
No, without inputting it in your calculator, because some of you don't remember. Some of you were asking me yesterday on the quiz, wait, how do I put like a table in my calculator to get the slope? Because I remember my teacher taught me last year, but that's a cheating way. That's why I didn't teach you again this year. This year in algebra, you actually have to know the math way, because they're going to ask you like to show your work. And on a STAR test, you might be like, wait, I can just do the cheating way on the calculator on the STAR test. But no, because on the STAR test, which so far you guys still have to take because you're in high school algebra, and you still have to pass the STAR test, they're going to like show you what are my answer choices for my work. So they're going to ask like letter A is like my answer choice for my work. Letter B is the work. Like they're not asking for final answers, because I know you can just put, well, some of you know how to put this in your calculator. And I'm not even going to show you because I know some of you don't remember and it's the cheating way. Okay, I'm going to give you like 10 more seconds to think about it and then give me your ideas. Okay, so without putting it in your calculator and getting the magic number to just like boop, 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 fill in the blanks. Okay, what is the actual math way? Like, so there's adding and subtracting and maybe multiplying going on in here. What is the actual math way? Kip, what do you think you have to do?
You take 16.7 and you subtract 1.2 from it. You can divide that by the numbers in between 2 and 17.
Okay, hold on. So Kip is saying take 16.7 subtracted by 1.2. Okay, so you get 15.5. Now what do?
You like divide 15.5 like for the numbers in between 2 and 17.
So what am I dividing 15.5 by?
Like 13 for 14.
What? So I'm dividing it by 14.
By like whatever's in between 2 and 17, and then you have the numbers.
Like, I don't understand when you say whatever's in between 2 and 17, like the number of blank spaces?
If you're 1 to 5 and 1 to 5. Yeah, it's 5.
Yeah, by 5.
Okay, so you're dividing it by 5? Okay, so hold on. So Kip, what am I dividing 15.5 by?
By like 5, so it takes up the blank spaces.
Okay, so I'm dividing it by 5 because there's 4 blank spaces? Okay, so we're dividing by 5?
Yeah, and then that's like what takes up every box.
But why am I dividing by 5 if there's 4 blank boxes?
And then you divide it by 8, then you would divide it by.
Okay, so guys, you might be right, but I want it to actually make sense to everyone, because so, like, I want to be able to find a way that I can't just be like, oh, divide by 5 because there's 4 boxes. Like, I want it to make sense so I can explain to the whole class then why this might or might not make sense. Yes, Tessa.
Well, you do 15.5 divided by 5, then it'd be 3.1, then you do 15.5 divided by 8, and then you get the answer, then you divide by 11. Is that what you mean?
No, because you add 3.1 to 1.2 and then add 3.1.
Yeah.
Okay, so you're adding 3.1, adding 3.1, adding 3.1, adding 3.1, and hopefully that'll get to 16.7.
Yeah.
Okay, so let's try, because I don't even remember what I did this morning. So 1.2 plus 3.1, so technically that would be 4.3. And then 4.3 plus 3.1, that gives me 7.4, plus 3.1, that gives me 10.5, plus 3.1, that gives me 13.6, plus 3.1, that gives me 16.7. Okay, so let's clarify then. What, Kip, why did you want to subtract these two, 16.7 and 1.2 to begin with?
Because that'll give you like the amount of like numbers that it goes up. Like it goes up by 15.5.
So
From the starting number like 2 to the ending number 17, it goes up 15.5.
okay, so Kip is basically saying between 1.2 and 16.7, there's 15.5 like between, like digits between that. Okay, that's how much of a difference there is. Okay, so now Kip, why did you decide to divide it by 5?
Because like there's 17 has to be included in it, because if you didn't, then it would just leave you with like, if you didn't include 17, then you wouldn't be including 16.7, and if you didn't include 17, you'd have a bigger number to add to every single one, and then you would be like above 16.7.
Okay, so what he actually says is right, but I don't know if to all of your brains it makes sense. Because like he's thinking of like kind of like backwards logic. And it totally is right, and he is right, but I don't know if mathematically, just in your brain, all of you can wrap your brain about like why his thinking makes sense. And his thinking is going to make sense for every single problem that looks like this. Like if I threw at him completely different numbers, his way makes sense. But I worry that not all of you understand his way. So let me also, because this is not the way I did it, but I think that it's pretty good that you actually thought of that, because I didn't even think of that. This is the actual algebra mathematical way, okay? I want to know how many to add, to add, to add, to add, to add. So aren't I kind of trying to find the slope? The slope is what is your change? How much am I changing it by to add, to add, to add? Well, to find slope, I have 2 points. Can't I say, oh, I have the points 2, 1.2, 17, 16.7. So let's find the difference between here and here. So here's my x1, y1, x2, y2. So y sub 2 minus y sub 1, divide x sub 2 minus x sub 1. Let's find the slope. Okay, so the slope would essentially be, I don't know, 16.7 minus 1.2 over 17 minus 2. I get 1.03, and it's repeating. Oh gosh, so I don't even want to write it because it's repeating. But this is, remember, slope is how many, so maybe I can change it to a fraction. To change a decimal to a fraction, I hit alpha y equals, and then this fourth option is f to d, fraction to decimal, hit enter. So it's 31 over 30. Okay, so this is really what this is. But this is saying for every one box, if the pattern were plus 1, plus 1, plus 1, plus 1. But it's not plus 1, it's plus how many? 3. Do you see how the very top, I'm adding 3, plus 3, plus 3, plus 3. I'm adding 3. So if my slope is for every one step, I'm adding 31 over 30. Don't I have to multiply it by 3? Because this is every 3 steps, every 3 steps, every 3 steps, every 3 steps. So I'm taking 31 over 30 times 3, and I get, oh, wait, what? Oh, 31 over 10, which is what? So alpha y equals fraction to decimal, the 3.1 that he just so happened to get as well. Okay, so you know then that you're adding 3.1, adding 3.1, adding 3.1, adding 3.1. That's the actual algebra way. So either way, I don't care how you get this answer, but you need to know, are you going to choose Kip's way? Are you going to choose the actual algebra way? Are you going to find your own way that still makes sense for every single possible problem? But you need to find a way. And maybe if you still don't understand either of the two ways that were explained today, I can explain it to you again. Vaughn?
So like, the way that you did it, if you have more numbers after 16.7, would you have to divide it by that number too? Like, how many, or would you just?
No. So Vaughn, if I had more numbers after 16.7, are you saying like the numbers are filled in or they're not filled in?
Yeah.
Okay, so let's say I have enough. Okay, so the reason why it would still be plus 3.1 and it would work for here plus 3.1 and it would still work out is because it says the table is linear. And remember, linear means it has the same adding. So it wouldn't say that it's linear if it were something completely different. So I can essentially grab any 2 points, this one, or if this was filled in, so it would be 20 and 19.8. Like I could essentially grab these two and still get the 3.1 answer because it's linear, because linear lines have the same slope. Does that make sense, Vaughn?
Yeah.
So basically, if it's linear, because it says it's linear, I can grab any points in this table and I would still get the same slope because linear lines have the same slope. Does that kind of make sense? Well, no. So if you're doing Kip's way, you would still divide by 5 because you're looking for the numbers in between. So like, so let's say that like if this was 10.5 and it was already included, then Kip would subtract this number from this number and divide it by 3 because there's 3 in between. And that would be the number you add. Or like if Kip did this, he would subtract 16.7 by 10.5 and divide it by 2 because there's only one square in between that you need to fill in. Okay. All right. Are there any final questions? I know that this one was kind of hard. It takes a little bit of practice. That's why I saved it for last. Okay. Then